Consider the following statement about a simple polygon. If it has an interior angle sum of 360, then it's a square. Well, clearly a rectangle has an interior angle sum of 360, but it is not a square. And that's a clear counterexample. In fact, any quadrilateral would have done. Write the converse statement, state whether it's always, sometimes, or never true. So if it is a square, remember that this is the original statement of P and Q. So the converse has Q and P switched over. So if it's a square, then the interior angle sum is 360 degrees, and that is always true. Write the inverse statement and state whether it is always, sometimes, or never true. So the inverse keeps P and Q in the same places, but it negates both statements. So this one would be, if it does not have an interior angle sum of 360 degrees, then it is not a square. And of course, that's always true. And the contrapositive statement, well, that swaps P and Q over and negates, so it'll be the swapping of this one above. So if it is not a square, then it does not have an interior angle sum of 360 degrees. And that's sometimes true. It's not always true, and it's not always true because, for example, as we pointed out at the beginning, here we have a rectangle. That's not a square, but it does have an interior angle sum of 360. So this last one is just sometimes true.